Suppose this is your sample space S. You have a set inside S, that is the set A, and you have another set called B, okay, that is outside A. This is B, and there is a portion of B that lies entirely inside A. Okay, this is A intersection B. So what are the things you are getting from information that you are getting from this picture is that you have A intersection B. Okay, now if you find the ratio of this probability and probability of B, this will give you the conditional probability of A with respect to B, denoted by this vertical line. Okay, similarly you can find probability of B intersection A divided by probability of A, that will be your probability of B conditional A. Okay, since A intersection B and B intersection A are commutative, there is no harm in writing A intersection B. So there is a beautiful relation between them, that is probability of A conditional B divided by probability of B conditional A. You can calculate it by dividing it throughout, that is probability of A divided by probability of B. Always remember, while calculating this probability measure, okay, while you are calculating, remember that this B can never be equal to 0. Okay, so this set is non-empty. Okay, this can never be equal to 0. Okay, the condition applied, okay, should never be equal to 0. So that is the thing that we noticed. So what will be probability of A when it is restricted to A? This will be nothing but 1. Okay, this is the thing you should also observe. Okay, this is the conditional probability. Few more things that I am going to tell you is, what is probability of B complement A when B and A are independent? Clearly, if two sets are independent, then this will be nothing but probability of B. Okay, these are the results that we are going to use in some later lectures. A conditional B will be equal to probability of A when A and B are independent. Okay, when A and B are independent. This is the condition. Okay, this is one thing. Again, probability of A union B is equal to probability of A plus probability of B. When they are disjoint, when A and B are disjoint, then this thing will definitely happen. If A intersection B is equal to phi, okay, this thing will happen. So these are few results I think we will be using, and you should also know that this thing happens. Okay, thank you.